No. There we go. Okay, so here's what we're going to talk about today. Yes. We're going to distinguish between a windmill and a wind turbine. We're going to talk about different sizes of wind technology, how it works, what are wind resources like in the United States and in Pennsylvania. We're going to talk about how much it costs and their lifespan. There's a lot of misconceptions in the wind industry, so I'll touch on those. And then how does it tie into green buildings, specifically LEED. Okay, so one of my biggest pet peeves from working in the wind industry is when people call a windmill a wind turbine and vice versa. A windmill is actually, they work on different principles to make the blades spin. So a windmill grinds grain or pumps water. You get a lot of torque with a windmill, whereas a wind turbine, you're using that to generate electricity. So the scales of technology, we've got distributed or small residential technology. And these are usually something that you can use on at your house or a barn or a small business. They can either be standalone with batteries or connected to the grid. Usually if you have batteries, they're going to cost a lot more because of the extra cost of the batteries. Okay. There's also a community scale. So a lot of people don't know that there's an intermediate scale of technology, but this is sort of emerging as pricing structures are a little bit difficult to overcome in the U.S. So these projects are usually owned and serve a community, so less than 10 megawatts, maybe a handful of wind turbines, like maybe 5. There's also the utility scale, which is what you think of when you think of wind energy, the really big wind turbines that have wind farms. And they are usually generated, owned and operated by utility companies or by developers. And then there's also offshore, and we don't have any yet in the U.S. It's all in Europe. But we do have some demonstration projects that are going up and down the East Coast. There's one off the coast of Massachusetts, and there's also one. There's a demonstration project going in Virginia, and then there's also one in Oregon, which is West Coast. But to give you an idea of the scale of these, this is you can see on-site community scale, utility scale, and also the large wind turbines, and that's compared to the Washington Monument over there, so you can see just how big they really are. The biggest one there is a 5 megawatt, and to date, the biggest wind turbine now being developed is an 8 megawatt wind turbine by Vestas, so it's even bigger than this. Here's a couple pictures of some distributed systems. This is a SkyStream 2.4 kilowatt. If you're in a good wind resource, it might meet a third of a house's annual electricity needs. And then the Bergy 10K is that's on a 120-foot tower, and if you notice, there's 2 different types of towers. You've got a lattice tower, and you also have a monopole. The lattice tower is actually the reasons why you would want one versus the other is the lattice would be good for training, whereas the monopole might be a little less expensive because there's less materials, less construction units to deal with. Also, on the other side, you can see that there's on the Bergy, there's booms sticking out from it, and those are for wind vanes and anemometers, which are used to measure the wind. So, community wind power, a good example that I found was at Apogee Stadium at the University of North Texas. The stadium was actually built to LEED Platinum, and they have 3 100 kilowatt hours, North and 100 LEED turbines. And the wind energy actually accounts for a third of the stadium's energy. Yeah. And then this is another example of a community wind turbine. I don't know if you guys can see or not, but this one actually has guy wires that are connected to the ground, and that's probably a Gaia. It's a different manufacturer, but they do make 2-bladed wind turbines. And then utility scale wind power, that's me. And this is actually out on Route 30 in Somerset County at one of the wind farms of GBA. And my favorite thing about this picture is that they have this nice gate up across this road. It could just run right around. It's kind of funny. And then we also have vertical axis wind turbines. So there, not to my knowledge, there aren't a lot of large-scale vertical axis wind turbines. We have a manufacturer here in Pittsburgh. It's called WindSnap, and I was hoping to get in touch with them before this, but I'd like to learn more about them, but they have a 20 kilowatt and a 40 kilowatt, I believe, and then there's other ones actually on the mall in DC. Okay, so how do wind turbines work? First, where does wind come from? It's actually, as Fred mentioned last week, it's a form of solar energy. So sun beats down, it keeps the air on Earth unevenly, so that creates wind. And then, so the wind will hit the blades, it'll cause them to spin. It's going to spin a low-speed shaft, which is connected to a high-speed shaft, and it's going to turn a generator, which is going to create electrical energy. Pretty simplified, but there's some parts of the wind turbine you can see. They also have, I didn't really go into it in this presentation, but the importance of measuring the wind. Where for solar, you can, I mean, there's sun everywhere, but wind energy is a little different animal where you need to be able to put wind. So the importance of measuring wind is really important, and you'll find an anemometer and a wind vane on almost any utility scale wind turbine. Not almost, on all of them. For that purpose, they actually control the yaw drive, which is going to turn the turbine into the wind if there's a shift in wind direction. So to generate electricity, what do you need? You need wire, you need copper wire, and you need a magnet to create an electrical field. So as your blades spin, they're going to spin a rotor, which is going to spin your magnets, and it's going to create electricity. There's also, so here's parts of a wind turbine, and a little bit more simple of a diagram. I will mention that the nacelle part, those on a utility scale turbine are as big as a bus, a school bus. Yeah. And you can see in this one that there are brakes. If there's extremely high wind speed, you can slow the wind turbine down or stop it.
Sorry.
Yeah, no, go ahead.
Controlled by someone office somewhere, system, or how do you slow them down?
Utility scale wind turbines are extremely intelligent. So they're going to use the anemometer and the wind vane, and they'll gather information on wind speed, wind direction. You can do it manually, but usually the computer inside the turbine is going to know. Like if you drive out 30, some of them are spinning, some of them aren't. They may have a problem that needs maintenance, or they might have something, an issue that needs to be worked on. They'll shut themselves down. The anemometer and the wind vane are constantly taking measurements and reporting it back to the computer, and they'll basically tell the turbine, like, you need to yaw so far to be able to make the most electricity, make the most production to spin the blades fastest. Does that answer your question? Yeah. But you can also do it manually. So wind turbines, they work on the principle of lift, just like an airplane. So unlike a windmill, when you have wind blowing over the blades, you're going to have, it's an airfoil. All the blades are shaped like an airfoil, so you're going to have an area of high pressure and low pressure, which is what causes them to spin. So some blade characteristics you've got to think about when you're designing a wind turbine or installing one at your home, or even if you're in a community. Blade length, width, shape. You can imagine if your airfoil is a little off, you're going to have a different power output. The weight, distance from the hub, material, pitch. If you have your wind turbine blades pitched at different angles, it's not going to spin correctly, and you can cause damage to the generator. Wind characteristics. So I was mentioning earlier, it's really important to be able to measure your resource, but wind is also really intermittent. So some of the concerns that arise are that it's not reliable. I'll get into that, but it's also seasonal. So wind is typically stronger in the winter months than the summer months, and it's also usually stronger at nighttime than it is during the day. So for that reason, it's really good when it's paired with solar, because solar is better during the day, wind is better at night. So if you're a homeowner, you're thinking about a hybrid system, it might make more economical sense if you do both. Wind speed also increases with elevation, and taller turbines can harness more power than shorter ones. I will mention there's a star there because there's a point of return where the cost, a lot of the cost of your tower is in your height, or a lot of the cost of your turbine is in the height of the tower. So the higher you get, the more money you're going to spend, but it might not be for as big of a return on investment. I'll talk a little bit now about the wind resource.
Is that why they put them on top of the mountaintops?
Yes, because the winds are going to be better, and also when you have wind energy on top of mountains, you're up above any obstructions. The wind turbines work really well when they have an even laminar flow hitting them, as opposed to a wind turbine that's stuck behind a house where you're going to get eddies, basically, of wind. So they aren't going to, if you've got a lot of turbulent wind, it's not going to produce as much electricity. And yeah, the wind resource is better.
Does that work better for the vertical axis turbines than like turbine things?
I don't think so. I wouldn't imagine that it would. I mean, I would still think that it's going to be still airflow the other way, so I think it would probably still benefit from having, yeah, and non-turbulent air. I don't know as much about vertical axis wind turbines just because the technology hasn't been around for quite as long as horizontal axis, and they haven't been quite as proven, I guess.
There's one of the Eden Park, one of the
okay, what is it, you know? Or
well, right over your Mall, you go down Freeport Road, and you'll see the Eden Park there along the road, and they have a vertical axis turbine.
Check those out. Yeah. There is a governing body, I guess you could say, it's the Small Wind Certification Council. They were established as a part of we as the American Wind Energy Association, and they evaluate wind turbines based on how long they've been around, if they're reliable, if they have been market tested. And to date, there aren't any vertical axis wind turbines that meet their standards. So this is the wind resource of the U.S., including offshore. You can see in the middle of the country, there's really great winds. The higher, darker the blue and the purple you get, the better the wind resource you're going to have. You can also see along the East Coast, we've got a really good offshore wind resource. It's in meters per second, and so anything above, like, I want to say like 6 to 7 meters per second is good for onshore wind energy. You can also see the southeast does not have that great of a wind resource. So there's what we have. How are we going to harness it? In 2008, the Department of Energy came out with a report called 20% wind energy by 2030, and it was basically a strategic plan to increase renewable energy in the United States and also to diversify our electricity portfolio. So in 2000, I think that map is 2009. This is where we were. This is how much wind power capacity was installed in every state. Beginning the southeast does not have a lot, but at that time we were at 29,250 megawatts of wind energy. So in order to achieve their vision for going forward by 2030, 46 states would have to have substantial wind development by 2030. You can see Pennsylvania is one of those, and the ones with wind turbines off the coast, those include offshore wind development. The squares and little dots in the state, the black open square represents the land area needed for a single wind farm, which is the installed capacity needed to meet the requirements for that state. The actual brown dot represents the land area that would be dedicated to those wind turbines. So it's 2% of that open area. A little more into the details. The goal was to get 20% of the U.S. power supply by 2030. When they wrote the report, with our current electricity use and efficiency where we were, it was 305 gigawatts that would need to be installed. As Fred mentioned to me earlier this week from the newest wind power conference, that has actually gone down to 260 gigawatts because of improvements in energy efficiency measures, and also because we were expected to grow with our energy demand, but we have actually stayed relatively flat. So to achieve that, we have to install 16 gigawatts a year. And as of the first quarter of 2014, we were at 61.3 gigawatts installed, compared to 2006, where we were at 11. So if you look at where we are on the graph, you can see that we're on track right now. but the green represents offshore. So you can see that we need to be sort of ramping up our production a little bit faster than what we are for offshore if we want to meet this goal. So this is wind power capacity installations by state. So you can see Pennsylvania, we are at 1,340 megawatts. Texas, by far, is the leader, and also California and Iowa. Iowa has really favorable guidelines and policies for installing wind. You can basically say they want to wind turbine and they can go ahead. Whereas in Pennsylvania or other places along the East Coast, you've got to go through a lot more red tape, I guess. So a look at PA wind by the numbers. We've got 1,340 megawatts, as I said, installed, which actually ranks us 15th in the nation. However, we have the 30th best wind resource in the nation. So comparatively, we're doing okay. We've got 720 turbines and 25 wind projects, which is enough to generate roughly 1.5% of our electricity. Based on our wind resource, we would have enough to meet 6.5% of the state's electricity needs. Wind development also brings in jobs and economic benefits for a region, including operations, maintenance, construction, and manufacturing. In 2013, we supported more than 2,000 wind energy jobs in the state, and which included a capital investment of almost $2.7 billion and land use payments to homeowners over $3.6 million. So that's pretty substantial. We've got 28 manufacturing facilities, including GBA, which is a leading wind turbine manufacturer. They were formerly only in Europe, and then they came to the States and Pennsylvania. They chose as their hub. And then another thing that I wanted to point out was the water consumption savings from wind projects on PA total nearly 730 million gallons a year. I don't have any slides on the benefits of wind energy because I know I'm preaching to the choir, but with all the other energy production methods, I think that this is a really important fact to know, especially with natural gas and fracking. And natural gas is cheap, but you use so much water, and wind energy uses none. So here's our wind resource, and you can see the farther, so anything that's a good wind resource is going to be like 5.5 to 6 meters per second. So that's the brown and orange area that you can see up here in your area. You also have orange, is a really good wind resource in the Jersey Valley area. So based on that, this is where our wind facilities are. I mean, you can see the comparison. It's pretty clear. This is also showing the manufacturing facility. So. Not yet, but I do think that they have a technology demonstration project plan for offshore, but in like Erie.
So if Erie has so much potential on the turbine.
I think because what they are trying to do is do offshore wind in the Great Lakes, but I don't think that. I think the technology is still. Yeah, and it's still. I think. I don't want to say emerging because it's not the correct term, but we don't have any in the U.S., so I feel like maybe manufacturers or developers might be dragging their feet a little bit to be the first ones to install it, especially in the Great Lakes area. Whereas if you're off the coast of Virginia, 25 miles, plus the added cost of transmission and distribution is really high when you put it way out in the water as opposed to on land. That makes sense. But I do think that last I heard, they had a demonstration project. They were going to install a couple of turbines to see how it went, basically. But I think it may be postponed. I think it.
The project offshore of Cleveland called Icebreaker. It's only 6 or 7, like test projects offshore wind. They didn't win the DOE grant, but they seem to want to be about 6 or 7 turbines. There'll be a demonstration project. 3 to 5 megawatts of grid or there'll be a demonstration project to show the
technology. Right.
And it'll be tougher than the lake with ice. We didn't have to use technology to mitigate the problem of the ice.
That's interesting. So what Fred mentioned about the demonstration project, the Department of Energy put out a grant award and awarded several states along the East and West Coast to do technology demonstration projects, and they're each going to be demonstrating a different technology. For instance, the one off of Portland, or I think it's West Coast, I think it's Oregon, they have the grant to do a floating turbine. So basically, it's a turbine that you would think of utility scale, but it's attached to a floating triangular hub, and they tethered it. They moored to the ocean floor, but it's floating. Whereas, like Virginia, they're doing a twisted jacket foundation because we have a very shallow continental shelf out there that you need a different technology. So up and down the East Coast, there's different technology demonstration projects that are going, going in anywhere from like 12 to 20 megawatts of energy in just a couple of turbines. So what does it cost? Excuse me. A residential wind turbine, depending on how large it is and what state you're in and what installer you use, what manufacturer you go with, can be anywhere from $10,000 to $75,000 to be installed. Like I mentioned before, a lot of that cost is in the tower. If you go with a lattice tower, you want to climb it really easily, then for some reason you don't really need to, but it would be more expensive. Monopoles are cheaper. You also need to weigh production versus height. So for a residential turbine, it's usually not going to be worth it if you can't get above 45 feet. So the higher you go, the more energy you're going to produce because, as I was mentioning, you need laminar flow. You don't want to have turbulent wind energy, so you're going to have more production the higher you go, but you're also going to have more cost. A small commercial wind turbine, anywhere from $75,000 to $650,000 installed. And then up to your large-scale turbines, they can cost anywhere between $3 and $8 million for one turbine installed. And that's before any like tax subsidies or credits or anything like that. So misconceptions about wind energy.
Sorry.
Yeah.
I may include this later, but what are the general paybacks? You know, if wind energy is a third of revenue or state, what does that payback period look like?
It really depends on what your project is, where you are, how much wind energy you're going to be able to produce. So if you've got a really great wind resource, you're going to install an appropriately sized system without oversizing it. Sometimes people oversize them and you're not going to be able to get enough wind energy to spin your blade, but it's not going to produce what you want it to. Depending on your tax incentives, I mean, there's just so many it depends in there that you can't really say like 10 years. Like, you can't really. It's hard to say what that would be, especially sorry, with the price of electricity. If you're somewhere where the price of electricity is really high, you're going to obviously be able to pay it back faster. So. For utility scale, I'll get into that in 1 second. So some common misconceptions about wind energy are the cost, the reliability, how they look, sound, the shadow flicker, property values, fire and ice throw, construction, decommissioning, birds and bats. These are all common concerns that come up when we talk about wind energy. So the cost, the concern is that wind energy is expensive, and wind on a utility scale is actually very competitive with conventional energy sources. It's the second most cost-effective new power generation facility to be built, first being natural gas. So if you think about that and where natural gas is headed and what it is, fossil fuel, eventually we're going to run out of it. It's going to be more cost-effective to install a wind farm. Also with that, you aren't considering any externalities such as your water use. So the cost of drinking potable water to frack for gas, that's not accounted for. So you were curious about the cost. In February of 2012, the cost to install a new wind farm was 69 cents per kilowatt hour. So another thing that you can consider when you're talking about wind being expensive is integrating it into utilities actually hedges against price volatility. So you know that you're going to have this set price of electricity for the next 25 years. You know that it's not going to go up because wind is free. Once you've installed it, all of your costs is up front. That $3 to $8 million, you have to pay that when you install it. You know? So, and it's also continually improving the technology is to make them more efficient so that you can make a return on investment sooner. Reliability. Some people say that wind energy is not a reliable source of electricity generation. Wind is intermittent, but it is reliably intermittent. You know when it's going to be windy, and you can predict for it. And generally, electricity, the energy production operators, they're used to balancing load with demand. Just another factor that they would have to include in balancing that whole portfolio.
I've also heard that in a lot of windy areas, the wind blows 80 to 90% of the time. So, in other words, you're getting some production most of the time.
Right. I know this is a really full slide, but another concern is sound. We like to say sound because noise has negative connotations associated with it. So some people are concerned that wind turbines are loud and can cause health problems, also known as wind turbine syndrome. Have any of you guys ever heard of wind turbine syndrome? Yeah, okay. So a study was conducted by Nina Pierpont. She was an MD, PhD, and she said that wind turbines can cause a disruption or an abnormal stimulation of the inner ear vestibular system, and that it causes quivering, nervousness, fear, a compulsion to flee, and even tachycardia. So she did this whole report on wind turbines causing this, and it could also trigger nightmares and cognitive development issues in young children. So in 2009, the American Wind Energy Association put together a scientific advisory panel to study this, see what she found, if it was reputable or not. So the panel they put together was doctors, audiologists, and acoustical professionals. And they found that based on the levels and frequencies of the sounds emitted by turbines, that they didn't find anything that could possibly have a direct effect on your health. I also included here the sound, how loud a turbine is. I don't know if you guys can see it in the back, but this is an air conditioner. And this is if you're standing 300 meters away from a wind turbine. This is your refrigerator running in the background. 300 meters is usually the common acceptable common setback distance for a wind turbine from a business or a residence or from a property line. So that's, you can hear something between an air conditioner and a refrigerator. I've been to a wind farm, I've stood underneath them, and have cell phone conversations standing debating one. The loudest thing with a turbine is actually the yaw drive. When the computer kicks on and says, hey, you need to turn to spin into the wind, the loudest thing is going to be the yaw drive turning the hub stay into the wind. Shadow flicker is caused when the wind turbine blades spin in late afternoon or early morning at sunrise or sunset. This is a problem that is experienced more in Europe than it is in the U.S. because we're at lower latitude. And so what happens is the sun is beating in, and you're going to get a flicker effect because there's shadows being cast by the wind turbine blades. This can be easily mitigated if you have proper siting by not putting a turbine right next to your house, by not putting it so that you're going to have this. Some people say that it could cause seizures, but again, there was another study done that said people with photosensitive epilepsy usually require strobe light flashes 5 to 30 seconds, and large turbine blades cannot rotate that quickly. Property values. Some people say that wind turbines will decrease the property value of a surrounding area. NREL actually did a study on the impact of wind power projects on residential property values in 9 different states, with 7,500 different homes, all within 10 miles of 24 different wind facilities, using 8 different pricing models, and they found that there were no conclusive results. So individually, yeah, I'm sure it happens maybe here or there, that there might be some, someone doesn't want a wind farm in their backyard, and they might say, I'm not going to pay as much for this, but I think it's really individual preference, and there wasn't any conclusive evidence that said that they would have lower property values. Fire and ice throw. Concern is that wind turbines will spontaneously catch fire, as clearly depicted in the picture, or throw ice accumulations in the winter. So usually a turbine is not just going to catch on fire. The reason this would happen is if the braking function is not working correctly and it overheats and it may catch on fire. Or sometimes if there's a lightning strike which hits it, that could also happen, but the turbines are grounded, so it shouldn't happen that often. As far as ice throw, in the wintertime and places that get a lot of ice or a lot of snow, the concern is that they're going to be spinning, they're going to be throwing ice long distances. I really don't think that this will work because of the lift principle. So if you have your blades covered in ice, you're going to be changing the shape of your airfoil, and it's not going to prevent them from spinning. So the blades are going to be stopped, and you also will be able to manually stay shut down, so you're not, even if for some reason they were able to spin. Construction and decommission. The concern is that construction can destroy land and turbines will remain an eyesore after their useful life is over. Abandoned coal mines, landfills, and brownfields are really good sites for wind turbines as long as the wind resource is good. Mostly landfills can actually do a combined methane recovery and wind turbine, which would be really cool. Wind farm. And then, so the creation of roadways, noise, construction, wildlife, there's a complete and total environmental impact assessments that have to be done in the permitting process before you even get anywhere near having construction start on a wind farm. So those issues are all met by criteria that the developer has to follow. The decommissioning process also has minimal impact. If you think about it, all your roads are already there. You're not going to be disturbing a lot of habitat. You're just taking it down and removing it or maybe repurposing them. So birds. Wind turbines kill large populations of birds. In actuality, less than 3 in 100,000 bird fatalities are attributed to wind energy annually. That was according to the 2007 study. And I want to put that into perspective with collisions with buildings, which is 97 to 976 million annually. Environmental toxins, estimated 72 million birds are killed annually. And then domestic cats, I like to throw that one in there. But the key word there in that one is songbirds. So when you think about what kind of birds you might be taking in a wind farm, is it going to be your bluebirds, or is it going to be your predators, your falcons, your eagles? And can you handle a couple of bird takes? That's what it's termed when a bird is killed by it. It's called a bird take. And wind farms are actually permitted to have a certain number of bird takes in a year. And if they exceed that amount, they actually have to shut down. Yeah. Or they can, it's kind of like a renewable energy credit where you can actually buy bird takes from another farm. I don't think that happens very often. So it makes it difficult to start reducing the populations unless you how much you're impacting the population unless you know how many are out there. So, yeah.
So why are they sited so far apart? Is that to, not affect like flows of flocks of birds?
So wind turbines?
Yeah.
Actually, the reason that they're sited the way they are is because, like I was saying, the whole thing about laminar and turbulent flow, the reason they're offset is because when a wind turbine spins, not going to capture 100% of the wind energy, right? So there's going to be wind that's flowing through behind the wind turbine, but it's going to be really turbulent. So if you put a wind turbine directly behind a wind turbine that keeps cycling like this, you're going to have lower energy production. So, and that's another thing that the developers need to consider when they're siting their wind farms and which direction the prevailing wind is coming from.
There's also a horizontal area, there's a whole to the dynamic problem. It hits the turbines, it sucks the energy out of the atmosphere, right? And the energy right behind the turbines is less. So avoid that close all around it. Also, far enough away to the horizontal.
That's actually a really good point, and it's a great lead-in to the concern about bats. So the reason there's a concern with bats is similar to birds that it will diminish bat populations, but for completely different reasons. So birds strike turbines, and by the way, the bird striking a turbine is a non-issue with a residential turbine because the blades will spin faster on smaller turbines, and birds will actually see that as an opaque circle and fly around it. Plus, it's only one turbine, whereas the large ones, they're actually, the blade tips moving 150 miles an hour. Looks like it's moving really slowly, but it's not. But with the bat, there's a pressure difference created when the blades are spinning. So you've got high pressure and low pressure, and that pressure differential is actually causing the bat to explode because they're such delicate creatures. So if they get caught in that, they explode. So the thing with bats also though is bats are nocturnal, right? So that's the best time for wind energy production usually. But what are they doing out at night? They're eating, right? What are they eating? Bugs. Do you have a lot of bugs when it's really, really windy? Not usually. So there was another study that was done, and they basically did an experiment where they shut down the wind turbines when there were high bug populations, I guess, and they found that they could mitigate a lot of bat deaths just by shutting them down on certain times. And they also, they fly with sonar. They also have, I guess, devices that you can put on the wind turbine that will send out a sound to let them know that they need to fly around. So, pretty cool. And the wind industry also has helped to fund research for the white nose syndrome, which is a threat to bats in the Northeast. So they are also helping to fund research to make sure the bat populations are healthy. So, green buildings and wind energy. So I was asking around, and I found, okay, so wind energy is located in an energy and atmosphere credit and LEED. And you can either have on-site generation or off-site generation per project. And off-site generation would be, for instance, if you wanted to buy green power from a wind farm or from an electric utility, or it could be carbon offsets, or it could also be renewable energy credits purchased. So for on-site generation, you need to be able to demonstrate both of the following: that total energy is met with directly with renewable energy systems. And for off-site generation, a little confused on the contract part, but if any of you know this, maybe you can help me clarify. But you would need to have a minimum 2-year for an existing building or 5-year contract for a new construction building in place with a commitment to renew on an ongoing basis. And resources that you're purchasing, so the wind farm would have had to come online after January 1, 2005. This is to prevent. The reason there's a date threshold is because they don't want you to be able to buy renewable energy credits that were generated from a hydro facility that was built 20 years ago. So it's really helping to spur renewable energy development and promote that development. So talk about RECs. So the green power and RECs must be green E energy certified or the equivalent. And your carbon offsets can mitigate scope 1 or 2 emissions. And for the on-site generation in existing buildings, EBON, you can have a 5-point limit, or for new construction, you can have a 3-point limit. Up to 10% of your electricity or your energy generated or used would come from wind energy or renewable. For off-site generation, the project has to have a minimum of a 10-year contract with the fuel provider. And the contract, the fuel, so they fuel, for instance, the wind energy, has to stay with the RECs. So when you generate wind energy, sorry, I just coughed directly into the microphone. Super. When you generate electricity from wind energy, you also are generating renewable energy credits. The reason that they say they have to stay together is because, for instance, they don't want you to be able to sell those renewable energy credits to fossil fuel power plants that buys them, so that they don't have to make any energy efficiency improvements or anything like that. At least that's my hunch. So for off-site, there's a 2-point limit in BD&C. If you get 50% of your energy, you can get 1 point, and 100% would be 2 points. So for exemplary performance, you can have, for existing buildings, 10% of the total energy use is met with on-site renewable energy. This is a step-by-step guidance in order to go through to get renewable energy on-site or use it off-site. You would want to check out your opportunities you have available to you, ensure that you're going to be eligible to use these systems, conduct a cost-benefit analysis, establish a project goal, how much do you want to meet, what do you want to power, what are you going to offset, and then calculate your potential contribution, and then figure out your recs and offsets if it's going to meet your project goal, and then get your green each certified project and figure out your points. So that's it.